Good morning, afternoon, everyone. Welcome to Unit 2, Angles and Triangles. For this unit, we'll continue talking about some of the things from last unit, but hopefully we'll be able to solve problems involving the sum of angles and triangles, be able to solve multi-step problems involving angles inside and outside of triangles, and be able to classify triangles and use properties of special triangles. So you can see some of the important vocab there, and we'll talk about each of those as we get to it. So by now I would assume everybody knows that triangles are three-sided. Okay, we have ways to classify them by side and by angle, and we'll use both of them to classify. So the first one is equilateral, which means three equal sides, and pay attention that all angles are 60 degrees. Equilateral, equal sides, also means equal angular, equal angles. Isosceles means two equal sides, two equal angles. So I remember that because I have two eyes. Now, the two equal angles are always going to be the ones that are across from the equal sides. Okay, and notice the markings I'm using here. Those mean equal angles. These little dashes on the sides mean they're equal or congruent. Congruent, remember, means equal length. Scalene, no equal sides, no equal angles. You step on a scale, you're going to weigh different than somebody else. If we go by angle, a right triangle is one angle equals 90 degrees. An acute triangle is all of the angles are less than 90 degrees. So I remember that all angles because acute starts with A. Obtuse is one angle is greater than 90 degrees. So those are kind of 6 classifications that we have. So if we practice some classifying, we can start with the angles. So I see right here that all of angles, so what I'm really checking for is, do I have a right angle? Do I have an obtuse angle? I don't in this. So this one's going to be acute because all angles are less than 90. I do have two equal sides here, so that means it's acute isosceles. For number 25, I check my angle. I have an obtuse angle right here. So it's obtuse. I don't see any equal sides, so that means scalene. For number 27, I see a right angle right here. So it's right, and I see two equal sides. So that means isosceles. Now, if everybody was to draw a triangle on a piece of paper, and I know nobody has a protractor to measure angles, okay? Label all vertices. A vertice is a corner, an intersect point. And if we were to measure all those angles, everybody should get the same thing. And some of you may already know what it is. Everybody should get the same thing. And what everybody get with the three interior inside angles should be 180 degrees. So the three angles inside of a triangle always add up to 180 degrees, and that's the triangle theorem. So practicing that a bit. If I look at number 1, I have two of the angles given, and I'm missing the third one. So I'm going to call this x. So to solve this, I know that x plus 23 plus 24 would have to equal 180. So if I combine the like terms, I get x plus 7 equals 180. If I subtract the 1 on both sides, I get x equals 33. For number, I'm going to search just so you can tell the difference. For number 3, remember this 3 is right here. So I would have 90 plus 2x equals 180. So I combine like terms, 160 plus 2x equals 180. Subtract the 160, I get 2x equals 20. I get x equals 10. So as always, I would encourage you to pause, to go back, rewatch it, all of those things. All right, now these ones are a little tricky. And for these ones, what we're going to do is, we're going to use a lot of those things we used from last unit. So we can work our way around here. So what I did is, I see this is 65 degrees. I see I have two lines that make an X. Remember about vertical angles. So if this is 65 and it's an X, that means this one has to be 65. I see the same thing with this 123. This is 123. This has to be 123 because they're verticals. Now, Bay just learned I have a triangle here. So X, I'm going to write up here. I know X plus 30 plus 65 has to equal 180. So if I were to solve for that, I would get X equals 85. So now I know this would be 85 degrees. Now if I look at this angle and this angle, so those three angles, they all form a line. So if I call this Y, remember a line is 180 degrees. Okay, so I'm going to move this over here. So I know 8 plus 65 plus Y 180. 8 plus 65 is 150. If I subtract that from both sides, I get Y equals 30. So now I know that's 30. So now I can, let's see, what color should I use? I can use it. So now if I come over here, I have this triangle. I know two of the three angles, so let's call this Z. Z plus 30 plus 65 is 180. I have to do a lot of steps before I get to my final answer. So if I subtract the 9, I get Z equals 85, or question equals 85, and that's my final answer. So look at what you know, look at what you can solve for, and just keep working your way around. So if I go down and do another example, and I do have to zoom out here. So there is ways to do this problem. But the first is I see this triangle right here, where I have two angles. So if I call this X, X plus 20 plus 60 would have to equal 180 because the angles in the triangle have to add up to 180. So I get X equals 180, which means X would be 100. So now I know this is 100 degrees right there. Now if I look, I have two angles right here. If I call this Y, that would have to add up to 180 degrees because they form a line. Y plus 100 would equal 1. So Y would have to be 80 degrees. And now I have this triangle where I now know two of the three angles and for the third, so I'll call that Z again. So Z plus 47 plus 80 would have to equal 180. If I combine like terms, I get this. Oops, that's supposed to plus, sorry. So I would get Z equals 53, which would be my question mark. So work your way around, find what you need to find. So some special triangles. We talked about equilateral a little bit. So all the sides are equal. That means all the angles are equal. Since all the angles have to add up to 180, and there's three of them, that means each one would have to be 60 degrees in an equilateral triangle. In an isosceles triangle, we have two sides equal, which means the angles opposite them are also equal. So we kind of go opposite the side to find the angle. In a scalene triangle, if all three sides are equal, that means all three angles have to be equal. So if I look at some examples here, for instance, number 29. Notice all the sides are equal. We talked about that. In an equilateral triangle, if all the sides are equal, that means all the angles are equal. They all have to be 60 degrees. So in this case, X just equals 60 degrees. I'm going to go ahead and do number 32, and then you can do 30 and 31 because I want to get one that's not equilateral, that's isosceles. So number 32, it says measure of angle 2 equals X plus 91. So that'd be kind of confusing, but I'm going to cross off the 2 and just put X plus 91. Now, notice the two equal sides. So that the two angles opposite them are equal. So if that's 49, this has to be 49. So now I have all three angles inside there. So I could do X plus 91 plus 49 plus 9 equals 180. If I combine like terms, I get X plus, let's see, that would be 189, which means x would be negative 9. Now, x can be negative because if I plugged it back in, I would still get a positive angle measure. So as always, if you have any questions, email, ask them in person. But good luck. Practice the ones that I didn't do on here. There'll be a video to check your answers, and then there'll be some graded questions. Have a great day.